this video, we are going to explain about the project title WildFishNet Open Set Wildfish Recognition Deep Neural Network with Fusion Activation Pattern. Introduction. Fish play a vital role in marine ecosystems, impacting the survival and growth of other marine organisms while maintaining the overall ecological balance. Human activities like overfishing and marine debris, coupled with climate and ecological changes, pose significant threats to fish survival and behavior. Traditional fish image classification methods are limited to known species, emphasizing the importance of open set recognition (OSR) to identify unknown fish species. The project introduces the novel WildFishNet algorithm, combining softmax and openmax activation functions to enhance recognition accuracy and mitigate prediction errors. Objective. The project aims to create WildFishNet, a deep neural network for precise open-set fine-grained recognition of wild fish species, enhancing the ability to identify unknown fish. The primary goal is open-set recognition, crucial for identifying unknown fish species in the complex and diverse open ocean environments. The project enhances accuracy by integrating softmax and openmax within WildFishNet, reducing prediction errors and improving recognition. The project compares WildFishNet's performance against established algorithms like ResNet 50 and MobileNet V2, emphasizing its competitive accuracy. Key machine learning metrics, including accuracy, precision, recall, and FN score, are employed to measure WildFishNet's performance, ensuring robust evaluation. Software and hardware requirements. Hardware requirements of the project are operating system of Windows, processor of i5 and above, RAM of 8GB and above, hard disk of 25GB and above. Software requirements of the project are: application is Anaconda, primary language is Python, front-end framework is Flask, back-end framework is Jupyter Notebook, database is SQLite 3. Front-end technologies used in the project are HTML, CSS, JavaScript, and Bootstrap 4. Working modules or flow of work. To implement this project, we have designed the following modules. The first module is importing the packages. This module focuses on importing the necessary Python libraries and packages, providing the essential tools for data processing, model building, and web development. Exploratory data analysis (EDA). EDA is a crucial step where the dataset is analyzed to gain insights into its characteristics, distribution, and patterns. This step is fundamental in understanding the data structure and features. Image processing. Image processing is employed to manipulate and enhance the images of fish species. Techniques such as normalization and shuffling are applied to prepare the images for model training and testing. Splitting dataset into train and test. The dataset is divided into a training set and a test set, typically using an 80:20 or 70:30 split. This division is essential for training and evaluating the machine learning model. Building the model. This module is dedicated to creating the deep neural network model, WildFishNet, which incorporates the fusion of softmax and openmax activation functions. The model is designed to achieve fine-grained recognition of wild fish species. Training the model. The model is trained on the training dataset to learn the patterns and features of the fish species. This training phase is critical for the model to make accurate predictions. Flask framework with SQLite for sign-up and sign-in. The project incorporates the Flask web framework and SQLite database for user authentication and management. This module enables user sign-up and sign-in, ensuring secure access to the system. The given input is pre-processed. Input data provided by the user is pre-processed to align with the model's requirements. This step ensures that the model can make predictions based on the user's input. The trained model is used for predicting the result. The trained WildFishNet model is deployed to predict the species of fish based on the user's input. The model leverages its learning to make accurate predictions. Final outcome is displayed. The project's final outcome, which includes the predicted fish species, is displayed to the user. This result provides valuable information to the user based on their input. The project enhances accuracy and robustness by employing an ensemble model with softmax and openmax fusion along with batch normalization. This improved model is used for making final predictions, ensuring more accurate fish species identification. A front-end user interface is built using the Flash framework to facilitate user testing. Users can interact with the system, input data, and receive predictions through this interface. Algorithms used in the project are WildFishNet. WildFishNet is the primary deep neural network developed in the project. It is designed for fine-grained recognition of wildfish species and employs fusion activation functions, softmax and openmax to enhance accuracy. WildFishNet is the project's innovative model. ResNet 50. ResNet 50 is one of the backbone algorithms used for comparison in the project. It is a pre-trained convolutional neural network CNN architecture with 50 layers. ResNet 50 is known for its deep architecture and is widely used for image recognition tasks. MobileNet V2. MobileNet V2 is another backbone algorithm compared in the project. It is designed for efficient and lightweight image classification, making it suitable for mobile and resource-constrained applications. WildFishNet Batch Normalization. This is an extension of the WildFishNet model that includes batch normalization. Batch normalization is a technique used to normalize the input to a neural network layer, making it more stable and efficient during training. It helps in improving the model's ability to select relevant features for accurate predictions. Comparison graph. This is the accuracy comparison graph. On the x-axis we have the accuracy score and on the y-axis we have the algorithm name. And from this graph we can say that extension WildFishNet batch normalization performs well. Accuracy is a measure of the overall correctness of a classification model. It calculates the ratio of correctly predicted instances, both true positives and true negatives, to the total number of instances. This is the precision comparison graph. On the x-axis we have the precision score and on the y-axis we have the algorithm name. Precision is a metric that assesses the accuracy of positive predictions made by the model. It calculates the ratio of true positives, correctly predicted positive instances, to the total number of positive predictions, true positives plus false positives. This is the recall comparison graph. On the x-axis we have the recall score and on the y-axis we have the algorithm name. Recall, also known as sensitivity or true positive rate, measures the model's ability to correctly identify all relevant instances in the dataset. It calculates the ratio of true positives to the total number of actual positive instances, true positives plus false negatives. This is the F1 comparison graph. On the x-axis we have the F1 score and on the y-axis we have the algorithm name. F1 score is the harmonic mean of precision and recall. It is a balanced measure that considers both false positives and false negatives. It is calculated as 2 times the product of precision and recall divided by the sum of precision and recall. It provides a single metric that balances precision and recall, making it useful when we want to consider both false positives and false negatives in the evaluation. Execution. To execute this project, first we need to open the code folder which contains the project source code files. This is the code folder. This is a static folder. This folder consists of files related to CSS, JavaScript and Bootstrap. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html and more, which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is the model file which contains algorithm information which will be loaded into the project code during runtime. This is notebook file. This is a Jupyter notebook file which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. First, we need to copy the path of the code folder from the address bar of the file explorer. I am copying the path. Open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python space app.py. Here I am typing python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, localhost which is this and port which is this. Now copy this local link provided by the Flask framework. I am copying the link and paste this copied link into any web browser. I usually prefer Google Chrome and hit enter. The homepage of the project is displayed in the browser. This is the front end built using Flask framework. If we are a new user, we need to register first. So click on register. So here we need to enter all these details to register, but I have already registered, so click on login. So here we need to enter the username and the password which we have created and then click on submit button. We have logged in successfully. So here we need to upload the image, and after uploading the image we will predict the type of fish species. Now click on choose file. Now click on upload button. So here we can see this is predicted as Chelonia midos. Let us upload some more images. We can see this is predicted as Caranex sex fasciatus. And this is predicted as Trianodoepisis. So in this way, by uploading the images, we can predict the fish species. The conclusion of the project is WildFishNet's fusion of softmax and openmax activation functions along with batch normalization significantly improves recognition accuracy in identifying open-set wildfish species. This innovation ensures more precise species recognition. The model excels in fine-grained species identification, a crucial aspect for effective fisheries management, biodiversity protection, and environmental monitoring. This capability supports the conservation and sustainable management of marine resources. The project's evaluation demonstrates WildFishNet's superior performance over established algorithms like ResNet 50 and MobileNet v2. It outperforms these benchmarks in terms of accuracy and essential metrics, underlining its effectiveness. The model's innovation holds significant promise for applications in marine science, fisheries management, and environmental monitoring. Accurate species identification is essential in these fields for the protection of marine ecosystems and the sustainable use of resources. WildFishNet's contributions are valuable for these critical applications.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.